What's up, everyone? Welcome back. Patrick here. Moving on to the next question. So we are given this trapezoid over here. Notice that there's a lot more detail in this trapezoid versus the other ones that we've been dealing in the previous videos, and I'll go over the details in a second. But we're given this trapezoid over here, and we have to find the length of MN, this length over here, and we also have to find the length of EF, which is this line going down the trapezoid right there. So a couple of things. Notice that the trapezoid are the outer lines right there, and then notice that this line BC and then the line AD are parallel. So those are the bases of the trapezoid, and then the other two sides over here, they are non-parallel sides. Another thing I want to mention is that notice that this M and this N over here, those are the midpoints of these sides here, because notice that this side, or this length over here is 6, and this length over here is 6. So because these two lengths are equal, it means that this is the midpoint of this entire side. And then same thing over here. So in previous questions, we were told that M and N were the midpoints. In this case, you have to notice that they're the midpoints because this length and this length are the same. Okay, so notice that we're actually dealing again with the trapezoid mid-segment theorem. So we know from just as a quick review, if we have a trapezoid, and by the way, it doesn't have to necessarily look like this, right? It could be flipped over, and this could take many shapes just as long as two of the sides are parallel, that there is one pair of parallel sides. So just as a review, if we have midpoints over here on the non-parallel sides, meaning this and this are the same, this and this are the same. In this particular question, it's 6 and 6, but these don't necessarily have to be the same as those right there, but in this case they are. So as long as these are the midpoints here, then we know that this length is going to be the average of these two lengths, right? So if we had X, Y, and Z, it means that if we take the average lengths of those two bases, the average of those lengths, that's going to give us the length of that mid-segment line. Okay, so that's what we're going to be applying here, because notice we have to actually find MN here. We have to find the length of that mid-segment. And that's actually going to be the easier part. The more tricky part is going to be finding the length of this EF over here. So we'll get there in a sec. But if I redraw this trapezoid without all of those parameters over here, so we could add stuff up. So notice that this entire length here would be 12. That entire length would be 12. Then notice the top length, this is 10, and then this is 10. So this is 20 over here. And then notice that this here, AF, is 3, and then FD is 3. So that entire base has a length of 6. And so at this point, we don't even need the 12s, but at this point we have enough information to calculate what that mid-segment length is going to be, right? What MN is going to be, because it's going to be the average of those two lengths, right? Which in this case is going to be 1326 divided by 2. So the answer to number 1, pretty simple. It is just 13. Now, what about the length of EF? So this one is going to be a little bit more tricky. We have this over here. Now notice that this line that's coming down, it is a perpendicular line to the bases, to both bases, because if both bases are parallel, right, we know both of these are parallel, then this here is going to be, this line is going to be perpendicular to both bases. And so what we can do, if you think about it, is we can kind of shift this line over and then make another line over here, and then this line and this line are also going to have the same length. And then notice that right here, what we create is a right angle triangle. So if we redraw that portion, we end up with a right triangle right there, right? Because if we shift this over, then this is also going to be 90 degrees. So this portion is going to be 90 degrees. Now we know that this over here, this length, CD, is 12, right? The 6 plus 6. What we're solving for is this length, so we can label that X, right? We're solving for EF, which is the same as that length. We're just shifting it over. The problem is we need this over here. And then if we have the length of this, then we could just use Pythagoras theorem to solve for that X. Problem is, how can we get that? So we know that this, from here, from E to C, right, this is 10, but we don't need that whole thing. We need from here to there. How can we get that? Well, notice that if we come down here, notice that this to this is 3. We're told that this is 3, which means that this to this is 3 as well. Okay, so there's kind of a lot going on here. So notice that from here to here is 10, right? From E to C is this 10 over here. But then from E to this point, okay, E to this point, so from here to here is 3. So what's the remaining length going to be? From this point to C, well, it's going to be 7, right? Because the 3 plus 7 has to equal that total length of 10. And so this length over here in this right triangle that we are dealing with is going to be 7. And then from here, we can use Pythagoras theorem to solve for that X. Notice that, remember, Pythagoras theorem is a squared plus b squared equals c squared. The c always has to be the hypotenuse, so that's going to be the 12. Then the a and the b, it doesn't matter which is which for the x and the 7. So we'll have x squared plus 7 squared equals 12 squared. So we'll have x squared plus 49 is equal to 144. Bring the 49 over. We'll have 144 minus 49 like that, which would give us 95. So x squared is equal to 95. So that means x is equal to the square root of 95. Right, and I'm going to leave it as an exact value. Right, so EF has a length of root 95, and if you want to get the decimal, it's going to be 9 point something. I'm going to leave it as an exact value. A lot of times textbooks will have this solution over here. Okay, so that's how you can figure out that length of EF. You can just kind of shift it, then notice you're dealing with a right triangle, right? We already know that this is 12. The trick was just figuring out that this portion was 7 using this length down here, right, which is the same as this length, and then using this total length of 10. Then getting the difference of those, noticing that we're dealing with 7. Then you can use Pythagoras, you get root 95.